We are pitching Matrix, an AI-powered learning platform for aspiring software engineers. Nico, Aryan, Schwabe, and myself are all master's student in AI and software engineering, so we are well qualified to build this. Technical interview prep is a uniquely frustrating and painful rite of passage that every student has to go through in order to secure a high-paying job. Companies usually pull questions from LeetCode, but the lack of good resources causes students to spend countless hours just to understand a problem, let alone solve it.
When I first started doing LeetCode problems, I realized this is the most academically difficult thing I've ever done in my life.
Dude, I'm not gonna lie to you. It's not because I found it fun. I would be slamming my desk in frustration, pulling my hair out in frustration, and then I'd be like a slap across the face, and the question difficulty would say easy. And I don't care what anybody says. Every single person that started out coding was exactly like this. LeetCode is hard. Not only because it's hard to be good enough to solve questions to land a job at high-paying companies, but also because it's hard to know how and exactly where to start.
Yes, I sacrifice sleep. Yes, I sacrifice my non-existent social life. And yes, I probably studied LeetCode style coding problems for around 1,000 hours.
There's some online threads in Reddit and Quora people dealing with LeetCode anxiety, LeetCode phobia, and just overall being a well-developed software engineer, however, still having to come back to LeetCode and struggling with it when they have to find new jobs.
I personally spent 300 hours just to get competent, and the goal of Matrix is to work backwards to create an all-in-one AI-powered solution for technical interview prep with the next generation of learners in mind. We will need a modest amount of funding for our minimum viable product, which is a classroom demo. In order to accomplish this, we need to host our app somewhere in the cloud, so there's going to be some cloud costs. And additionally, since we're working with LLMs, we're also going to need to account for the API keys costs. And lastly, since we are going to take a visual approach towards learning, in creating high quality animations, we're going to need to invest in audio visual equipment so that our work can be impactful and engaging.
In terms of milestones, currently we do have a demoable product with a few LeetCode problems that demonstrate the main idea of what we want to produce. However, we want to include user accounts so users can save their progress and statistics. We also want to have more more inclusion of AI agents that are over time will be trained towards each user and basically tailor their learning experience of how to do LeetCode problems to each user. Not only that, but progression trees so users can learn iteratively by building on previous topics, and overall include more animations with voiceovers to properly explain topics and concepts. And here's a little demo.
Now, say you look at a LeetCode problem and your first hurdle is the wording. All you have to do is highlight what's confusing to you, and you can get an explanation from Neo, your personal interviewer. Now, he's not just any generic LLM that you'd find on the web. He's a fine-tuned agent that's aware of everything that you see on your screen. Let's give him another example. And you can see that based on the framing, he's well aware of the problem. Now say this gives you enough information to come up with a plan. A common pain point in solving these problems is knowing when you've spent too much time and you need to cheat and look at the solution. But a better idea is always being steered in the right direction, as with a real interview. With confirmation that we are on the right track, we can develop our code a little bit further. Let's say we're ready to test. Looks like there's an error. We've upgraded to LLM-powered error handling, so the LLM can quickly identify and pinpoint where your issue is and give you a suggested fix. And you can apply the fix by pressing checkmark. And then when we submit, we should see that our code is now running, though some of the test cases are failing. Let's say we don't know what the reason is, so we're going to take a hint. Now, as with a real interviewer, Neo is going to give you something to think about, not just a blanket answer. This one here is forcing us to consider when we're incrementing components. In practice, what this means is that this needs to be tabbed in. Let's take another hint. We see that this hint here is suggesting using a different data structure. And in practice, what this means is that we need to use a set, which is customary in graph-related problems. But if we don't know what that is, we can just look at our toolkit and then expand to find the code. If we still have questions, we can just ask about it, and Neo is going to elaborate further, and then we're going to have these two new tabs where we can animate it and interact with it. And we see that this animation pulls from this set of numbers here, and it's going to attempt to add these numbers to a set. And with a set, you can't add duplicate numbers, so any duplicates are going to be marked red and not added. We can interact with this animation by changing up the numbers. So for example, we can change to 1, 9, 1, and then hit test, and we see that we get a new animation with the exact numbers that we put in. Let's take this code and paste it into our editor. Now let's figure out how we can refactor our code to use a set. And Neo is just going to go ahead and explain it to us. But we're just going to paste in the solution for the sake of time. Now Now we're going to hit test to finalize our submission. And we see that all our test cases pass, and the LLM is going to grade us. It looks like I got docked for using I and Node to refer to Vertex. But I'm not just going to throw you in headfirst into the problem. That hasn't worked for me, so it definitely won't work for you. I'm going to build your intuition through a strictly visual approach. Each unit is going to have a high-quality explanation and an exercise so that you will learn by coding. Zoom in on this one. It's asking us to create an adjacency list from a list of edges. So let's turn this in. All the tests pass. I've handpicked these exercises for them to be extremely reusable code snippets that you'll take with you to your next problem. As you can see, this code snippet is used in solving this problem, this problem, and this problem.
Moving on from that, we can talk about our competitors. It's going to be one of them is NeetCode, and we can see on screen there's a video about a minimum interval question.
How is this going to work? Like I said, we're going to need a min heap.
And we see that it's very overrated as it explains the solution, but does not really guide users on how to get to the solution. It also uses unprofessional visuals. Not only that, but our competitors provide a paywall, which can be pretty steep at times, and when it doesn't really seem useful as a lot of it can be outputted by ChatGPT. And overall is walls of text, paragraphs of text, of proofs that are just overall really hard to read.
Our customers are primarily computer science students who are looking to secure their first internship or job, and teachers who are looking to modernize their data structures and algorithms courses to better prepare the next wave of learners for the job market. We stopped several students at the CS Source Career Fair, and we met many people who are interested in our product, but few had the time to fill out the survey in between talking to companies. Here are just a highlight of some of the responses. We asked them questions where they rated how they felt, where 1 is strongly disagree and 5 is strongly agree. The first one of the questions being that students can imagine people that would find this tool very useful, and you can see that most of the students lean towards strongly agree. When asked whether Virginia Tech has prepared them well for technical interviews, though we have one outlier, most of them felt that Virginia Tech is not a great source of technical interview prep, which is crucial as a computer science major in landing that first job. And when asked whether they would prefer a technical interview prep style course centered around this tool, we can see that all the responses were either neutral or lean towards agree. In addition to students, we also asked instructors. We got 2 instructors who are incredibly interested in using this tool for their classrooms, that being Professor Hamuda and Professor G. Their research areas are in digital education and AI and networking and privacy. You can see that both of the professors can see ways that they can improve their classes to better equip students for the job market. And this is interesting because the students themselves felt that the classes could be made better and more tailored towards interview prep. When asked whether data structures and algorithms is best explained visually and interactively, but both the professors strongly agreed. And when asked whether Matrix is an effective tool for students in a classroom setting, both of them, of course, were interested in using it in their class. We are currently in the process of working out dates that we can demo this to the students of Professor G and Professor Hamuda's classes, which is really exciting.